Thank you for the introduction, Amy. Good morning, everybody. OH? No? No Buckeyes? I didn't think so. As Amy said, be talking about the pretensioned bent caps. We've been developing these pretty recently within about the past year or so, and we're pretty excited about their potential as a eventually be a standard to replace cast-in-place construction methods. So, basic quick overview. I'm going to talk about the cast-in-place bent caps that are currently the common practice, kind of poke some holes in them, show what the most common defects are with them that we're all very aware of. Then I'll talk about what I'm going to call the first generation precast caps. These were developed in the early 90s and have been used on a number of projects to address certain issues that are common with the cast-in-place caps. Then I'll move on to the second generation pretension caps that we've been developing for about the past year and talk about some of their benefits and how they can address a lot of the issues present with cast-in-place and even some of the precast issues. And then I'll give you a view of some of the current projects that these have been used on. So as we know, cast-in-place construction, it can be a very time-consuming process. You have to set up formwork, create your cages of steel, pour your concrete, let it cure. Commonly, the curing can take up to as much as 4 days before you can remove the formwork. And after that, based on some of our specifications, you have to wait until the bent cap concrete reaches 3,000 PSI before you can even start constructing on top of that. So it's a very time-consuming window, and you can see how if you have a lot of bent caps, that can create a big delay in the construction timeline. Another issue with cast-in-place construction, particularly for bent caps, is safety concerns. In this picture, you can see a number of safety issues. First of all, they're up over and they're a number of feet over a waterway, so there's a fall hazard, and this happens. Construction happens over waterways and roadways, and so there's potential for fall for the construction workers. Also, they have to perform their work on these congested and small platforms that just increases the risk that these construction workers are exposed to. Cast-in-place concrete quality, it can be very inconsistent. The concrete that they can batch either on-site or from a batch plant, it can vary in quality and consistency from batch to batch, and from the time it leaves a batch plant to the time it reaches the construction site. One of the biggest issues we see with the cast-in-place bent caps is the cracks at service loading. Here you'll see this is the IH-35 East at the George Bush Tollway Bridge, and we've got this bent cap here, and I've increased the visibility of these cracks that you'll get. And these are just due to service loading. No over extreme loading or anything. So in the early 90s, TechStop began working on some precast, conventionally reinforced caps. This here is a rendering of the Lake Belton project. The caps have been used on a number of projects very successfully, and they're used to address some of the issues I was discussing just moments ago with regards to concrete quality, cracking at service loads. Also, one of the other main issues is lower roadway closures, so impeding the traffic and vehicle use. So one of the projects in 1994, the US 290 Ramp G in Austin, this lower roadway here was a major roadway. It saw a lot of daily traffic, and one of the concerns was during construction that using a cast-in-place inverted T bent cap would close the roadway for a very long time. As you can see, the conventional construction cast-in-place caps would have taken 41 days to close the lower roadway to complete the construction. That's clearly too long, especially for as busy as a road that is. So they looked at an alternate, which was the precast inverted T straddle bent. The construction of this, this was cast off-site, shipped to the job site, and installed, and it resulted in closing the lower roadway for only 6 hours. So you can see a major, major reduction in construction time from days, months, to mere hours. Another successful project that was implemented was the Redfish Bay bridge. This is a half-mile stretch of bridge over the Gulf Coast. The great thing about this project is it contained 44 identical bank caps, and we all know that that is one of the major advantages of precast construction, that you can, if you have a lot of repeatability, you can cast these things very quickly and very economically. The great thing about this is being half-mile over the Gulf Coast, if you did cast-in-place construction, you'd have to barge concrete out or get slick lines, slurry lines to get the concrete out there, and that goes back to the quality of the concrete you get because you're just increasing the time from the batching of the concrete to casting it. So with some of the benefits of the first generation in mind, we recently have moved on to considering pretensioned caps. While the first generation precast caps help things with constructability and construction timelines, they still don't address some of the earlier issues with the service cracking or even some of the quality issues. So we looked into prestressing the bank caps because prestressing has added crack control ability, and it also has the same benefits of the precast first generation with expedited construction timelines. So first thing was our design concept. We basically wanted a symmetric strand pattern, and the reason for this is it'll eliminate camber. One of the things you get with pre-tension elements is camber, and for bent caps that can be an issue because of your connection to the support systems, whether it be columns or piles. So we decided to go with symmetric patterns, top and bottom, and on each face to eliminate that. And another thing that we decided to do, as you'll see in the picture, there's the A through Z and horizontally, and then the numbered vertical axes. This is the same as our text girder design. It's just we felt that this would be a convenient way for the precasters and for other engineers to recognize it. It's a fairly simple strand pattern. The design of these is currently what we do is we match conventional caps. So whatever the reinforcing necessary for a typical cast-in-place cap, we'll just match the number of strands. So say you need 7 top and bottom number 11s, you would just match that moment capacity. And same for the shear. We match the shear capacity with the stirrup spacing. The other thing that you have to take consideration into is the stress states. And the critical ones here are the storage and lifting. So right after they release it from the beds to when they move it to the site and lift it into place, as I'll show you later how they actually get it into place. You have to make sure that it never goes into tensile stress. That's a self-imposed limit because AASHTO will actually let you go somewhat tensile, but we, for our sake, have limited it to 0 tension because we don't want any cracks to develop before it's even in place. Then at service limits states, we have done stress checks to make sure that it doesn't exceed the AASHTO stress limits for tension because the only reason we're pre-stressing it is so that we don't get the cracks. So we want to ensure that at service load levels, this thing stays in compression or stays underneath the tensile stress limits that AASHTO has imposed. And you'll see here the figure is just the moment capacities. And the thing to note here is the development length of pre-stressing strands versus conventional reinforcement is different. So one of the things to consider when designing the pre-stressed alternative is the development lengths so that in those little kind of kinked regions that you still have adequate moment capacity, because if you have shorter caps or low reinforcing, you may have issues with the capacity in those regions. So fabrication and transportation, we see these as being delivered to the site in the same way as our text girders currently are. They'll be cast in the casting yard, and they can cast a number of them in a row because the caps typically are pretty similar, so cast them all and then ship them out to the site. Here is a picture of the installation. Basically what they do is they will take the cranes and lift it based on those lifting loops that you'll see here in the end bay of the column, or the cap. And they'll lift it up onto the columns in this case, which have reinforcement that extend out of the column, and they'll go through the ducts that exist in the pre-stressed caps. The nice thing about pre-stressed caps is you can cast all of your caps off-site in advance. You don't have to wait for the columns to be finished, the substructure to be finished. You can get that done ahead of time. So on average, one team of 5 workers can typically construct only about 3 cast-in-place caps in 8 days. So it takes more than a week to cast 3. For the precast caps, first generation, second generation, on average, you can get about 12 caps in 1 day. So that's a major advancement in speed. This project here, I'll talk about shortly, they had 18 caps on the one bridge. They finished 18 caps in 3 days, and the only reason it took 3 days is because they had a creek that they had to move all of their cranes and equipment across. One of the major design details with these caps is the cap-to-column connection, because with the cast-in-place caps, you can just form it up and cast the concrete around your reinforcement. However, with the precast ones, we have previously developed in the first generation a set of details where you have ducts running up through the cap at the column locations. And basically what you do with the crane is you just thread the rebar here up through these ducts. And after the cap is set down on the column, you grout it and move on to your next cap. It's very quick. It doesn't take very many people to do. So currently, these caps have only been designed for rectangular standard caps. They are designed for all of our standards on our website, but we haven't yet moved on to the aesthetic or inverted T's or straddles or anything like that. One of the main things you'll have to do when considering whether to use precast or conventional are some of your guidelines, like construction timeline. If it's an accelerated construction timeline, that's a good situation to use precast. Also, a large number of similar or identical bent caps is another good thing, because precast is great for repeatability. You can cast many of these in a row, especially for pre-stressing, because they can cast a number of these on the same bed at the same time. You'll have to check for your development length, as I mentioned earlier, with the moment capacities. Also, the confining steel. The end regions and the overhangs of those caps are the bursting regions for pre-stressing steel, so you need to ensure that you'll have sufficient stirrups in there to prevent bursting and cracking. Also, the exterior columns, too, we're providing some bursting or some confinement reinforcement in those regions around the ducts, just to help transfer some of that pre-stressing force through that area. And ensure the adequacy of cap to support columns, or support connections. So we have a number of different supports that are usable. So I showed you before the cap to column connection, which is a simple grouted connection through ducts. We also have, for our first generation, we have cap to steel pile, where you embed a steel plate and then weld the steel plate to the steel pile, and the concrete pile. So currently, we don't have any details for a concrete pile, but because in the first generation, it has a void where you put the pile in and then you grout through the void. But for the pre-stressed caps, we'll have to look into maybe increasing the size of the cap to account for enough clear cover for the pre-stressing forces. So some of the current projects that we're using these caps on right now: the Loop 1604 in Bexar County, San Antonio. This is on the northwest side of San Antonio. It has 36 bents, which are, so there's two parallel roadways, and there are 18 caps on the northbound, 18 caps on the southbound roadways. The great thing about these are the caps are all the same girder spacing, column spacing, and cap lengths. So they're pretty much identical, and it was very easy for the precaster to just cast them one after another. The second project that these have been designed for, but not yet installed, is FM 973 over the Colorado River in Austin, Texas. So this project only has 8 bents, 4 for a northbound bridge and 4 for a southbound bridge. While this doesn't have the added benefit of repeatability quite as much as the previous project, this construction project was on an accelerated timeline. So they had a very short deadline to try to get this construction done, and they wanted precast. They wanted a precast option to shorten their timeline. This one, I have a Google Map image because they have not installed these caps yet. So in conclusion, basically, reduce construction timeline. Precast caps, you cast them beforehand, off-site, while the contractor is doing their foundation work and substructure work and their earthwork. And you can just ship them to the site basically the same way we do with our tech skirters and install them very rapidly. On average, about 12 caps in a day you can do. Increased worker safety, basically while you still have workers who are up in the air and have to do those connections, they still are exposed to fall hazards, but the amount of time that they're exposed is reduced greatly. So while there is still some risk for fall hazards, the overall safety is increased because the time that they are exposed to these hazards is reduced greatly. And improved structural performance. The pre-stressing helps to keep these caps out of tension, and concrete hates tension. So we believe that at service level loads, these shouldn't experience any cracks. Acknowledgements, I'd like to thank Bear Concrete Works in San Antonio, Texas. They've been the fabricator who's been working with us to actually construct these caps, and they've been helping us with some ideas for how to improve it. And the 2 contractors, Texas Sterling Construction Company, they are the contractor on Loop 1604, and they did a great job. So currently, they did 18 caps on the one side of the bridge in 3 days. So they moved really quickly, and they had no issues with the installation of the caps. And Lane Construction is the contractor for FM 973. And with that, I will open it up to any questions you may have. Here in front.
Has there been any effort put toward replacing the caps on a cross slope?
So the question was, has there been any effort for placing the caps on a cross slope? And I'm going to go back to, let's see, I think there's a better picture. So here is the Loop 1604 caps. You'll see them one after another. And this bridge was actually a full super elevation curve. It went from about 2.5% cross slope all the way up to about 6.9% cross slope. And that's why you see the varying bearing seats. So what we did to address the cross slope was, instead of angling the cap, we cast the cap flat with the columns all to the same height, and we varied the height of the bearing seats. Because the other thing that you could do is you could angle the cap, but in that case you would have to angle the ducts within the cap that column connects through. And especially for something like a super elevation curve where it's varying, each of the ducts would have to have a different angle, and we felt that tolerances on that would be very difficult to get. And not only the tolerances, but each cap is different because it's a curve. So if they got the wrong cap on the wrong site, that could create huge issues. So what we did to address it was we just varied the bearing seat heights. We felt that was a little bit easier for the contractor to install. Any other questions?
Is there any concern about moisture being maintained that runs between the foundations and the cap?
So the question was, is there concern for moisture getting in between, I believe, like the column and the cap? So we have a standard developed for that cap to column connection, and I believe there's as you'll see down here, actually point. So there is that gap there, and what they'll do when they go to grout it is they'll put a collar around it, and they'll flow the grout all the way through and seal it up and let that cure, and to make a construction joint or make a joint with it. So we actually do have based on our standard for the connection, we have the contractor prove that they can actually do this properly, we have them do a mock-up of their grouting of the cap-to-column connection to show that they can get a adequate or an acceptable grouted connection. So the cap-to-column connection, we have standards for that. Those are based on the first generation, and the nice thing is it doesn't change at all for the second generation. So standards for the pretension cap, I believe we are in the process of developing standards. Currently, for the two projects that they've been designed on, we've just done basically a one-off design. We've taken the conventional design and matched it with a prestressed design. But I do believe we have standards in the process of being developed right now. They're not ready yet, but we are working on those.
I think with that, we're going to need to close the questions, and we'll move on to our next presenter. So if you have questions for Chris, maybe get with him right after this first session.
Yeah, feel free to see me during the break. We want to talk about these. Thank you for your time.